So today we'll be doing processor fundamentals, and this is chapter 5 from the 9618 computer science for AS level. And it's a pretty simple chapter once you understand it, and yeah, let's get started. So first of all, we need to learn about the CPU architecture. Okay, so let me just zoom in. So what do you guys know about the CPU architecture? Some of you might know that the CPU consists of parts that would do logical operations, arithmetic operations, and then there would be input and output devices connected to the CPU, etc. Right? But right now we're going to go into a deeper level of this. Okay, so there are four main things that we're going to learn under CPU architecture. Okay, so number one is ALU. ALU is what handles the arithmetic or logic processing needs of a program. Okay, handles the arithmetic or logic processing needs. Okay, so ALU handles the arithmetic or logic processing needs, which means the plus minus operations, all the calculations are done in the arithmetic logic unit, that is ALU. Okay, secondly, you have a control unit. Now control unit is responsible for managing the data flow. Okay, it manages the data flow, and it also synchronizes processes. Okay, and it ensures the execution of instructions. Okay, so ensures execution of instructions, and it synchronizes processes. So what that means is so at one time, suppose this is your CPU and there are two tasks that need to be performed. Okay, so if the user wants both these, if the user has requested for both these tasks at the same time, and both these tasks go to the CPU to ask for a resource or something, then notice how like both of this happens at the same time, so there might be an interrupt, right? So the control unit basically synchronizes processes, and it will give a certain time frame where this task can go and retrieve some data, and then after that this can go. Okay, so it basically just synchronizes and manages the data flow. Okay, so ALU handles the arithmetic and logic processing needs. Control unit manages data flow, ensures execution of instructions, and the clock. Okay, there's basically a clock which synchronizes processes. Okay, synchronizes processes. Now under this clock part, okay, clock comes under the control unit. There's two types. Number one is a system clock, and number two is an internal clock. Okay, so as the name might suggest, system clock is basically for the overall computer itself, and internal is for the internal part, right? So system clock synchronizes the entire computer system. Okay, synchronizes entire computer system. And internal clock is the electric signal controlling microprocessor operations. So this synchronizes and controls internal microprocessor operations. Okay, internal microprocessor operations. So hopefully so far you guys have understood what's going on here. Now coming to our third part of CPU architecture, and this is probably the most important part of this chapter. It is about registers. Okay, so registers act as storage components that allow very short access time, and there are two types of registers. There is general purpose registers. Okay, general purpose registers, or there is special purpose registers. Okay, number two, special So there's general purpose registers or there's special purpose registers. Okay, now before we move on, let me just highlight all these important parts. So first we learned about CPU architecture, and then we moved on to the first one, ALU, control unit. ALU handles the arithmetic and logic processing needs. Control unit manages data flow, ensures execution of instructions, and the clock synchronizes processes. And under clock we learned about system clock and the internal clock, right? So that's what we did there. Then coming back to our CPU architecture, we did registers. That's what we're learning about right now. And there's two types of registers. Let me highlight that. There's general purpose registers and there is special purpose registers. Okay, now let's dive into each one of these in depth. Okay, so in general purpose registers, the only thing you need to know here is ACC, and ACC stands for accumulator. Okay, accumulator. Now accumulator basically stores arithmetic and logical results during program execution. So accumulator is basically where the data of the program that's currently running is in the accumulator. Okay, so accumulator stores arithmetic and logic results during program execution. Okay, alright, so accumulator stores arithmetic and logic results during program execution. So that was our first type, and that's the only general purpose register, by the way. Okay, now moving on to our special purpose registers. There are 6 main types. Alright, so let's begin. Number 1 is index register. Okay, index register, for those of you who have started practicing paper 2, index is like a number, right? It holds the value of it's almost like SI number, right? So index register is short for IX. Okay, and it stores the indices to access specific memory locations. Stores indices. Indices is basically just index but in plural. Stores indices to access specific memory locations. Alright, so that is your index register, and that's our first thing. Then we have status register. Okay, status register is, the short form is SR. Alright, now status register is basically like a memory location where it's basically, it can be 1 or 0. Okay, and it's like a flag. Okay, so it contains flags and status info indicating various operations and conditions in the CPU. Okay, so it acts as a flag. Alright, it acts as flag, and status info is also stored here. Alright, so that is your status register. I think I should write these in pink so that it looks different, right? So number 1 is index register. IX stores indices to access specific memory locations. And number 2 was status register, which is basically a flag. Okay, status register SR. Alright, now next up we have memory address register. Memory address register. The short form obviously is going to be MAR. This is a very important one. So memory address register holds memory address being read from or written to. Okay, holds memory address of the data being read from or written to. And after this, our fourth one is program counter. Program counter is gonna contain the address of the next instruction that's gonna be executed. Okay, so let me write that down. So program counter keeps track of address of next instruction being executed. Alright, so after PC, our fifth one is gonna be memory data register. Memory data register, MDR. Notice how the MAR and MDR kind of looks the same. It's because the memory address register is gonna contain the address of the data, and the data in that address is the memory data register. Okay, so this holds the memory address of the data, and the memory data register stores data being read from or written to. Okay, and lastly we have current instruction register. Current instruction register, short form is CIR, and the current instruction register stores the data of the current instruction being executed. Okay, stores data read from or written to memory that CPU is currently executing. Okay, so that's it. Those are all of your registers. Okay, now it's a very good idea to make note of all of this because it's pretty important. So let's just go over all these things once again. So we talked about 1 minute, which color should I choose? I think I'll just go with the blue. Okay, so up until now we've done three main things. ALU is the arithmetic logic unit. It handles the arithmetic or logic processing needs. Control unit manages data flow. It ensures the execution of instructions. Yeah, so control unit manages data flow. It ensures the execution of instructions, and the clock synchronizes the processes. Now in clock, under clock you have two main clocks, system clock and internal clock. System clock synchronizes the entire computer system, and internal clock synchronizes the microprocessor, the internal microprocessor operations. Now moving on to registers, there's general purpose registers.